Okay, so today we are talking about rational problem solving, meaning applications with rational functions. So what we're going to be doing today is focusing on the setup of these problems, okay? We're not going to solve each of them, but we're really going to be focusing on the setup, okay? Because you will know how to solve them once you get them set up, okay? These problems are types of problems that might seem overwhelming at first, but if you'll kind of we're going to talk about 3 or so specific strategies today. If you just kind of look at the problem and figure out which notes problem it's like, you're going to be able to set it up just fine. Okay? You might not necessarily understand the underlying, like, why does this equation work, but this is the equation that just make sure you try and follow the strategies. Okay? So let's start with number 1. This is our first type of problem where we talk about people doing stuff separately and then people doing stuff together. So Shelly can paint a fence in 8 hours. Karen can do it in 4 hours. How long will it take them to do the job if they work together? So the first thing I'm going to do is define my variable. So I'm going to say let x be the time it takes them together. Okay? And here's how we're going to set up this equation. We're basically going to set up a couple of ratios and solve them. So Shelly can paint the fence in 8 hours. So 1 fence in 8 hours. Karen can do it in 4 hours. So 1 fence in 4 hours. We're going to add those together. And that's going to equal how long it takes both of them to do it together. All right, what do we need in order to be able to solve this? A common denominator. What would our common denominator be?
8.
Not just 8.
8 at 1.
8x, good. Because we have an x in this denominator here. Okay? Basically, think of this top number as the number of fences that they're painting. So 1 fence in 8 hours, 1 fence in 4 hours. How long will it take us to paint 1 fence together? Okay? All right, so what do I multiply this first fraction by? All right, and I'll come to you later. And what about our second fraction?
2.
And our last fraction? All right, so we have x plus 2x equals 8. So 3x equals 8. X equals 8/3. Okay, so you know how I've encouraged you to avoid mixed numbers? Well, in problems like these where you're talking about hours, days, stuff like that, it makes more sense to use it as mixed numbers. So it's okay to go ahead and write this as 2 1/3. But the important part comes when you turn this into a sentence about your answer. So what does that 2 1/3 represent?
Number of hours they can paint fence.
Yeah. Oh, sorry, yeah, 2 2/3. So they can paint the fence in 2 2/3 hours together. Because you've got to make sure, just telling me 2 2/3 doesn't tell me you know what you just found. You've got to be able to show me that you know what you just found. Okay?
When we write the sentences out, we're not allowed to write those things.
I mean, you can try and avoid that. Yes, that'd be great. So they can paint the fence. I'm just trying to save us some time here. Okay, so look at 2. 2 is another type of the same problem. Tim can stuff envelopes 3 times as fast as his daughter, Georgia. They have to stuff 5,000 envelopes for a fundraiser. Working together, they can complete the job in about 4 hours. How many hours would it take each of them working alone? So we set one person plus the other person equals the time together. So we know we're going to have 5,000 over 4 on one side of our equal sign because it takes them together 4 hours to stuff the 5,000. So we've got to figure out what variables we're going to use to represent the other ones. Now, would you agree that Tim's time and Georgia's time are related?
Yes.
Okay, Tim can stuff the envelopes 3 times as fast as Georgia can. So if Georgia stuffs the envelopes in 3 hours, how long will it take Tim? 1. Why? Yeah, it takes her longer, right? If he can stuff them faster, it takes her longer, right? So when we see 3 times as fast, automatically we want to say that Tim is the 3x. But who's the 3x going to be? Georgia, because it takes her 3 times as long. So we can let x be Tim's time. So this is 5,000 over x would represent Tim, and then 5,000 over 3x would represent Georgia. Okay, what's your LCD here? 12x. What do I need to multiply my first fraction by? Okay, what about my second fraction? 4. And what about my last fraction? 3x. So I have 12 times 5,000 plus 5,000 times 4 equals 3x times 5,000. You have your calculator. Make sure you use it. This would be 60,000 plus 20,000 equals 15,000 x. So we get that 80,000 equals 15,000 x. So what does x equal? 16 over 3. All right, so let's turn that into a statement. What does that mean? Yeah, it asks us how many would it take each of them alone. So Tim would take 5 1/3 hours. How long would Georgia need?
16.
Yeah, Georgia needs 16 hours. Questions on that? All right, so that's one set of problems. Okay? Everyone okay with those? All right, let's look at another set. Rosa can jog 5 miles downhill in the same time that it takes her to jog 3 miles uphill. She jogs downhill 4 miles per hour faster than she jogs uphill. Find her jogging rate each way. Now, these are going to start to feel a little bit like those systems problems we did earlier in the year, where there's not necessarily only one way to solve them, okay? I'm just going to show you the ways that I've kind of started leaning towards that make sense to me, but if you want to try another way, go for it. All right, so we need to remember that really important formula, distance equals rate times time. All right, so one thing that we know for sure is that they take the same time. So I can go ahead and say that t is that same time. What's the other variable we need though? No, we know the two distances, so that can't be a variable. one of the rates. I can't do both rates, but I can pick one, because don't you agree that the two rates are related? Yeah. So let's let R equal, we either need R to be the rate uphill or the rate downhill. It doesn't really matter, you just have to pick one and know which one you're picking. So let's go ahead and let X be the rate uphill. All right, so let's write our equation for uphill. What's her distance uphill? 3. What's her rate uphill? X or R. And what's her time? T. All right, let's talk about downhill. What's her distance downhill? What's her rate downhill? Just 4? It's going to be R plus 4. It's her rate, and then 4 miles per hour faster. Why is it not 4 times R? Good. It doesn't say 4 times as fast, right? Just says 4 miles per hour faster. And then her time is still the same. Now, the reason that this helps us so much, that the time is still the same, would you agree that if we got these both solved for t, we can set them equal to each other? Yeah? So go ahead and do that. Solve both of these for t. So I get t equals 3 over r and t equals 5 over r plus 4. So once I know that these are both equal to t, what can I do with these? Set them equal to each other. So 3 over r equals 5 over r plus 4. Now this is just a proportion, right? You can get your common denominator, but we know with these simple ratios, getting a common denominator is the exact same as cross multiplying. So whichever one kind of makes more sense to you. So I'm going to go ahead and take my next step. So I get 3r plus 12 equals 5r. 12 equals 2r. So r equals 6. Now this is when it becomes really, really important that you write your answer as a sentence, because r could be different for different people. So you've got to make sure you translate that into a sentence at the end. So what would I need to say? Good. Her rate is 6 miles per hour uphill and 10 miles per hour downhill. Does that make sense that she goes faster downhill than uphill? Yeah. Questions on that one? Okay, please go ahead and set up number 4. You don't need to go ahead and solve it. I just need you to get to kind of this step right here, the equation that you could keep solving. Make sure you define your variable and set it up. Okay, so depending on whether you let your rate represent the freight train or the passenger train, you're going to get two separate equations. Either of those are correct, just as long as you make sure you know which one you used. If you did not define R, if you did not define what rate you're talking about, then you're not going to know when you solve for R what you found. You're not going to know which rate you found, potentially causing you to miss the question. So it's really, really important that you define that. Are there any questions about setting this up? It depends on what you set up as your rate. If you let the R be the rate of the freight train, then the passenger train goes faster. So that's R plus 20. If you let rate be the rate of the passenger train, the freight train goes slower. So that's R minus 20. Okay? Now, obviously, in your homework, would you stop here? No, you would solve it. Okay? All right. But like I said, some of these we're just going to set up and not solve because we want to focus on getting the most out of them as possible. Read through number 5. All right, what do you think we're going to let our variable be here? And what is R going to represent? Look what it's asking you for. What's it asking you for? What's his normal bicycle speed? So that's what we're going to let our variable equal.
Is that how you know what your variable should be?
It's really going to help, yes. On the previous one, we were looking for 2 different speeds or 2 different times, something like that. That's when you have to decide which one you're going to represent. But if all we want to know is his normal bike speed, that's going to be our variable. Now, instead of setting up a freight train, passenger train, or uphill, downhill, we're now going to set up with the wind and against the wind. Those are the 2 things we need to set up here. Okay, so with the wind, what was his distance? So distance equals rate. What's our rate?
R plus 3.
Good. Make sure you put R plus 3 in parentheses. And then his time, again, was the same, right? It says same amount of time. Okay, how about against the wind?
24.
So 24 equals R minus 3 times T. Now, in this problem, it was easing you in. It said the wind added 3 kilometers per hour to his rate and subtracted 3 kilometers per hour to the rate. It's not always going to say that, okay? You've got to know anytime they talk about wind, current of a water, okay, airspeed, stuff like that, current of like a river. Anytime it tells you that, then when you go in one direction with that help, it's going to add to your speed, right? It's going to make you go faster. If you go against the wind or against the current, it's going to make you go slower. So you're going to subtract it from your rate. So just know it's not always going to spell it out for you. You got to be prepared to kind of add and subtract where you need to. Okay? All right, what do you think we're going to do from here? Solve them both for T. And then set them equal to each other. So this would be T equals 36 over R plus 3. This would be T equals 24 over R minus 3. And then we would set them equal. So 36 over r plus t, or sorry, r plus 3 equals 24 over r minus 3. And I feel confident that you can all solve from there. Yes? Yes. Okay. Everyone okay on that? So that's another type of problem, the wind type stuff, or the current, things like that. Uphill, downhill, those nature. All right, look at number 6. A basketball player has made 58 out of 82 attempted free throws. How many additional free throws must she make in a row to raise her free throw percentage to 90? Okay, so right now, would you agree she has 58 out of 82? Okay, what if she makes the next 5 free throws in a row? What would you have to do? Add 5 to the 58, that's it? And the 82, right? Because if she makes them, she also has attempted them, right? So if we let x be the number of free throws she can make in a row, then what do you think we're going to add to 58 and 82? X. And what are we going to set that equal to? 90 over 100 or 9 over 10. Either of those is fine. All right, go ahead and solve this one, please. Go ahead and solve this one, please. When you get your answer, make sure you turn it into a sentence. Don't just leave it as a value. Okay, well, we assigned our variable as.
Yeah, that
One.
Yeah, that's a lot of videos, so I didn't know. That's right.
All right. When you solved for x, what'd you get? 158. And then you need to turn this, and then you have to turn this into a sentence. So she would need to make 158 free throws in a row. It's a very challenging task right there. Okay, number 7. Please set it up, but you do not have to solve. Please set up number 7, but you do not have to solve. All right, so tell me the equation.
6 over 30.
6 plus x over 30 plus x is equal to 4 over 10.
Yeah, equals 40 over 10 or 40 over 100 or 4 over 10 if you would like to simplify that.
What is that 20% chance coming?
That 20% just tells you that right now she's at 6 out of 30, which is 20%.
Okay.
She's figuring out how she's going to be able to raise it to 40%. Okay? Obviously on your homework, would you keep going on this? Yes. Okay. Yes?
Would you be allowed to simplify the 6 over 30?
You can only cancel factors. 6 is not a factor. 6 plus x is a factor.
Okay.
Okay? Okay, you're planning a school field trip to a local theater. It costs $60 to rent the bus, and each theater ticket costs $5.50. Write a function, c of x, to represent the cost per student if x students sign up. So it's not asking you for the total cost. It's asking you for the cost per student. So what do you think? 60 plus 5.5x. What does that give us? That's the total cost. What do you have to do to the total cost to find the cost per student? Divide it by x. Okay? This is the exact same as saying c of x equals 60 over x plus 550. So if this is where your head went, that's totally fine. These two mean exactly the same thing. Okay? I'm going to go ahead and work with this one, but I wanted you to know that this meant the exact same thing. Okay, look at B. B says, how many students must sign up if the cost is to be no more than $10 per student? So this is what represents our cost. No more than. What does that mean? Less than or equal to 10. Everyone okay on that? All right, so this is an inequality, right? So we rewrite it as an equation. Set it equal to 10, and we would solve. So multiply by 10, or by x, so I get 60 plus 5.5x equals 10x. So 60 equals 4.5x. So we find that x is equal to 13 1/3. So what do you think that means?
14.
Yeah, we can't have 13 1/3 students, right? But if we have just 13 students, is it going to be less than 10? It's not. So we've got to go up to the next full student. If you weren't sure, could you plug in 13 and 14 and see which one works? Yeah. So what this means is there needs to be at least 14 students. Everyone okay with that? All right, we're going to skip 9 and move to 10. Okay, Jason drove 50 miles at a speed of x and then increased his speed by 10 miles per hour for the next 100 miles. The entire trip took him 10 hours. So we can already guess that he wasn't going very fast, right? He's going 150 miles in 10 hours. That's not very good. Maybe he's on a go-kart or a bike or something. I don't know. Okay, but we're still going to set this up. So we know our equation, distance equals rate times time. But this time we know the total time, right? Anytime you know the total time, you want to think now about the equation t equals distance over rate. All I did was divide both sides by r. The reason being is if I know my total time, what I'm going to want to do is add up the different legs of the trip to equal my total time. Okay? So in this example, what is my total time? 10 hours. Okay. What's the distance of the first leg of my trip? 50. And what's the rate of the first leg of my trip? X. Tells us that right here. Okay, we're going to add that now to the second leg. What is the distance of the second leg? 100. And what's the rate of the second leg? It's plus 10. Any questions on setting up this equation? When you're given the total time, this is how you want to set it up. Okay? All right, what are we going to need to do in order to solve this? All right, what's our LCD? X times x plus 10. All right, what do I need to multiply 10 by? Okay, what do I need to multiply the 50 by? And what about the 100? So I'm going to get 10x squared plus 100x equals 50x plus 500 plus 100x. What kind of equation is this? It's quadratic. So what does it need to be set equal to? 0. So I'm going to have 10x squared minus 50x minus 500 equals 0. Now remember, you have your calculator, right? So you have a couple options. Pull out your GCF and factor, which is what I would do. But you could also plot this on your graph, right? If you want to find the solutions, those are the same as the roots. So remember, we know how to graph a quadratic and find the roots. That's your option as well. Okay? I'm going to go ahead and save us some time and tell you that either way you solve this, you're going to get that x equals 10 and x equals negative 5. All right, what do you know about that negative 5? Yeah, you can't have a negative speed, so that's not possible. So what we need to do is turn this 10 into our answer. So our question says, how fast was he going on each part of the trip? All right, he was going 10 miles per hour on the first leg, and 20 miles per hour on the second leg. Yeah. I agree. All right. You may cross off number 11. Yeah, we crossed off 9, crossed off 11, and now we're on 12. Okay. A river barge travels at an average of 8 miles per hour in still water. The barge travels 60 miles up the Mississippi and 60 miles down the river in a total of 16.5 hours. Find the average speed of the current. What this is going to kind of do is combine that first set of distance, rate, time problems where we had like uphill, downhill, with the wind, against the wind. It's going to combine that with the kind we just practiced with the total time. Okay? We're going to combine both of those. So the fact that we've got a total time tells me that I'm going to use time equals distance over rate, because I've got two parts of my trip that I want to add together. Okay? What is our total time? All right, so 16.5 equals. And now we've got to do the distance over rate of each of the legs of our trip. What's the distance of our first part? 60. All right, now let's think about this. For his rate, normally the boat travels 8 miles per hour. But when he's going up the Mississippi, is he going like with the current? Is it helping him or is it going against him? So his speed of 8, is it going to get higher or lower? Lower. So could we do 8 minus x? What would that mean x would represent? Yeah, the speed of the current. All right, we're going to add that to the second leg. What's our second leg? 60 over 8 plus x. If we're going downstream, the current's helping us, right? It's making us go faster. Now, I'll admit, I'm not so much of a river person, okay? If you didn't, I know, shocking, right? You might not know which way is with or which way is without the current, which one helps and hurts. But we all know it's harder one way, it's easier the other, right? So you're going to have to add and subtract. It doesn't necessarily matter that you do it in the right places as long as you're going the same distance, okay? What would your LCD be here? 8 minus x times 8 plus x, okay? We're going to stop because I have confidence that you can solve that, and I'm going to let you get started on your homework. When you get your homework, you may omit numbers 6, 9, and 11. 6, 9, and 11.